In previous lecture, I discussed closed formula, iteration, forward substitution and backward substitution. Today, I will discuss one example of sequence and summation. Example 7. Conjecture a simple formula for an if first 10 terms of the sequence an are 1, 7, 25, 79, 241, 727, 2185, 6559, 19681599047. So here one sequence is given and it is asking to find the formula for an. Now just check, is it a AP? No. 1725, it's not a AP. Is it a GP? No. So is it related to 2 power 3? So 2 power 3 minus 1, it will be 8 minus 1, 7. 2 power 4, it will be 16 minus 1, it should be 15, but it's 25. So no, it's not related to 2 power n or something. So is it related to 3 power n? 3 power 1, 3, 3 minus 2, it will be 1, right? Next 3 power 2, it will be 9, 9 minus 2, 7, it's working. Then 3 power 3, it's 27 minus 2, it's 25. Yes, so we can say this sequence is 3 power n minus 2. So an equals to 3 power n minus 2. So I compared this term with 3 power n and we found it's 2 less than 3 power n. So the formula is an equals to 3 power n minus 2 and n varies between 1 to 10 as this is for 10 term. Now some sequence for first 10 terms are n square, it will be 1, 1 square, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 36, 49, 64, 81, 100, it's 10 square. Next nq, so 1q is 1, 2q is 8, 3q is 27, 4q is 64, then 5q 125, next 216, then 343, 512, 729, 1000. Next n power 4 sequence are 1, 16, 81, 256, 625, 1296, 2401, 4096, 6561, then 10,000. Next 2 power n, 2 it's 2 power 1, 2 square, 4, 2 power 3, 8, 2 power 4, 16, 2 power 5, 32, 2 power 6, 64, 2 power 7, 128, 2 power 8, 256, 2 power 9, 512, 2 power 10, 1024. Next sequence is 3 power n. So 3 power 1, 3, 3 power 2, 9, 3 power 3, 27. Next 3 power 4, 81, like this. Next n factorial 1, 2, 6, 24, 120, 720, 50, 40, like this. Next is Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, like this. Fibonacci sequence is sum of previous two terms. Next summation. Suppose we have a summation like am plus 1 till an, that we can write as sum j equals to m to n a of j, or simply we can write m less than equals to j less than equals to n. So this j varies between m and n. So here this j called as index of summation, and here lower limit is m and upper limit is n. And we use this symbol sigma for summation. Sum of j equals to 1 to n axj plus byj. So here if it is in term of addition, we can split it. So one sum for axj, another sum for byj. And if a is a constant, so we can take a to outside of summation. And if b is a constant, we can also take b into outside of summation. So a sum of j equals to 1 to n xj plus b sum of j equals to 1 to n yj. Let's see one example. Example 8. Use summation notation to express sum of first 100 term of the sequence AJ, where AJ equals to 1 divide J, for J equals to 1, 2, 3 till infinite. So we can write sum of J equals to 1 to 100, 1 divide J. So it will sum first 100 term 1 divide J. Next example 9. What is the value of sum J equals to 1 to 5 J square? So it will be 1 square plus 2 square plus 3 square plus 4 square plus 5 square. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. After addition, we will get 55. Next example 10. Sum of I equals to 1 to 4, sum of j equals to 1 to 3 ij. It is a double sum. When there are double sum, first we'll evaluate the inner sum, then we'll evaluate the outer sum. So first we'll evaluate this sum of j equals to 1 to 3 ij. So in place of j, we can write 1, then 2, then 3. So I plus 2i plus 3i, it will be 6i. Now we'll find sum of I equals to 1 to 4, 6i. Now in place of I, you can write 1 to 4. We can write 1, 2, 3, 4. So 1 plus 2 plus 3 plus 4, it's 10. 10 multiplied by 6, it's 60. Now see one theorem, theorem 1. If a and r are real number and r not equals to 0, then sum of j equals to 0 to n ar power j equals to ar power n plus 1 minus a divide r minus 1. If r not equals to 1, just remember this formula, it is important. And if r equals to 1, it will be n plus 1 multiplication a. So we are adding a n time, that's why we can multiply n plus 1 with a. Now example 11, what is the value of sum of s belongs to 0 to 4? So this index of summation can be continuous or it can be like this 0 to 4. So I'll simply add 0 plus 2 plus 4, it's 6. Next example 12, find sum of k equals to 50 to 100 k square. There is a formula 1 plus 2 plus 3 up to n square, that is n into n plus 1 multiplication 2n plus 1 divide 6. So this we can write as sum of k equals to 1 to n k square. So this summation 50 to 100, that we can split. We can write 1 to 100 minus 1 to 49. So sum of 1 to 100 k square minus sum of 1 to 49 k square. So this will be sum of 50 to 100 k square. And for this k equals to 1 to 100 k square, we have the formula. We can use this formula. So it will be 100 multiplication 101 multiplication 201, that is 2n plus 1 divide 6 minus, then formula for sum of k equals to 1 to 49 k square will be 49 multiplication 50 multiplication 99, 49 multiplication 2 plus 1 99 divide 6. Now after solving this, we'll get 297,925. So don't have direct formula for this, that's why we split sum from 1 to 100, subtract sum from 1 to 49. So now some summation formulas are like sum of k equals to 0 to n, a r power k are not equals to 0 is a r power n minus 1 minus a divide r minus 1. Here r not equals to 1. Then sum of k equals to 1 to n k will be n multiplication n plus 1 divide 2. It's like 1 plus 2 plus 3 plus up to till n. That formula is n multiplication n plus 1 divide 2. Next sum of k equals to 1 to n k square. It's like 1 plus 2 square plus 3 square till n square. that formula is n multiplication n plus 1 multiplication 2n plus 1 divide 6. Here we use this formula. Next, sum of k equals to 1 to n k cube. It's like 1q plus 2q plus 3q plus till nq. And here formula is n square multiplication n plus 1 square divided by 4. Next, sum of k equals to 0 to infinite x power k. X value is less than 1. Then its formula is 1 divide 1 minus x. Next, sum of k equals to 1 to infinite k x power k minus 1. X value is less than 1. Its formula is 1 divide 1 minus x square. So just remember this summation formula. These are important. We'll apply it in different problem. With this, I'm finishing sequence and summation. In next lecture, I will discuss next topic, that is cardinality. If today's lecture is helpful for you, please like, share and subscribe. Thank you.